In the previous video, we had talked about the difference of perfect squares. And we had said that if you have a sum of perfect squares, that's not factorable. However, when you start to deal with perfect cubes, you can factor both the sum and the difference of perfect cubes. Let's start by just going through. I am going to give you something that I want you to go through and use the distributive property in order to multiply x plus 2 in parentheses times x squared minus 2x plus 4. And if you could do that just for a moment, turn this off and on, and then you can turn it back on again. You can watch me do it. But it would be a good practice to have you use the distributive property and multiply those two factors. Okay, hopefully you've had time to go through that. I'm going to go through and use the distributive property to multiply this myself. So I'm going to multiply x times every term that's in that second set of parentheses. X times x squared gives me x cubed. X times a negative 2x gives me minus 2x squared. X times 4 gives me plus 4x. Then I'm going to multiply the 2 times everything. So I get plus 2x squared. I get minus 4x. And I get plus 8. If I go through and simplify that now, you're going to see that some things drop out. I have a subtract 2x squared and a plus 2x squared. Both of those drop out. I have a plus 4x and a minus 4x. Both of those drop out. And I'm left with x cubed plus 8. So what I have is I have a sum of perfect cubes. X cubed is a perfect cube and 8 is a perfect cube because 8 could be written as 2 to the third power. So I could rewrite this if I wanted to as x cubed plus 2 cubed, which then leads us to a formula that you will need to know in order to go through and factor out a sum of perfect cubes. And here's the formula. If you have two perfect cubes and you are adding them, they will factor down to a plus b in parentheses times a squared subtract ab plus b squared. Knowing that we have this x cubed plus 2 cubed, you can see that it will factor down to what we started with up here. What I'm going to do is I'm going to say my a is the same thing as this x, and my b is the same thing as that 2, which gets into what we have right here, the a cubed plus b cubed. If I go through and I say a is equal to x and b is equal to 2, what I'm going to have is I'm going to have x plus 2, because that is my a and b, and then I want x squared, because a is equal to x, minus 2x, with the a and the b, plus 4, because b is equal to 2. And if we look back at what we started with here at the very beginning, that's exactly the same thing. So this formula right here, I'm going to put an equal sign in between. This formula is the formula that you can use if you have a sum of perfect cubes in order to go through and factor it. Here's another example. I have the formula for the sum of perfect cubes written up at the top of the screen. So let's use that formula in order to go through and factor out 125x cubed plus y cubed. That is a sum of perfect cubes. And I can show that by writing down what each of the perfect cubed roots of this is. For 125, the cubed root of 125 is 5. So what I really have is I have 5x to the third power, which is equal to 125x cubed, plus I still have that y cubed. And what we're going to say is we are going to say that the 5x is equal to the a, and the y is equal to the b. So we're just going to put in the 5x and the y where the a and the b are in the formula. So the formula says a plus b. So a is equal to 5x. So I need 5x plus b, y. B is equal to y, so I have 5x plus y. Then the formula says I need a squared. Well, a is equal to 5x, so that's 25x squared. Subtract ab, so that's going to be minus 5xy, and then plus b squared. B is equal to y in this particular case, so I'm going to have plus y squared. And now I have gone through and I have factored the a cubed plus b cubed using that formula. Just like there's a formula for the sum of perfect cubes, there's also a formula for the difference of perfect cubes. And I have both of them written on this screen. Before we go through an example of difference of perfect cubes, I want you to notice that the formulas are very, very similar to each other. Really, the only difference is the operation signs. For the sum of perfect cubes, I have an addition sign, and for the difference, I have a subtraction sign. And then the only other thing that's different is that the subtraction sign in the sum of perfect cubes changes to an addition sign. Now we could go through and do a problem to prove that, but I'll let you do that on your own if you are interested. But this formula for the difference of perfect cubes will work every time. So let's go through an example of a problem. If you are given 8w cubed minus 27z to the third, and I want to go through and I want to factor that. First of all, I do need to recognize it is a difference of perfect cubes, because 8 is a perfect cube and so is 27. So I'm going to rewrite this here for a moment, and I'm going to rewrite it so it looks like it's perfect cubes. It's really 2w to the third power, subtract 3z, all that to the third power. And in that particular case, that means that my a is equal to 2w, and my b is equal to 3z. And now, once again, all I'm going to do is I'm going to substitute 2w for a and 3z for b in this particular formula that I have. So if I do that, first of all, I need a subtract b. So I'm going to have 2w minus 3z in my first set of parentheses. After that, I need a squared. Well, a is equal to 2w. 2w squared is equal to 4w squared. Then I need plus ab, so I'm going to be multiplying 2w times 3z. The 2 times the 3 gives me 6, so I have 6wz. And then I need plus b squared. Well, b is equal to 3z, so I need to square that, so I'm going to get 9z squared. And now I have gone through and I have factored this difference of perfect cubes. Here's one final example to look at. I have 4x cubed minus 32y cubed. And when I first take a look at this, it doesn't look like either of these terms are perfect cubes. But remember, if you can factor something out of a polynomial to start with, that's the very first thing you want to do. And I take a look at that and I see that I could factor a 4 out of both of those terms. So that's the first thing I'm going to do. I'm going to factor out a 4, and I'm going to end up with x cubed minus 8y cubed. Now, this x cubed minus 8y cubed is a difference of perfect squares. And once again, I could rewrite this if I want to. It's x cubed minus 2y in parentheses cubed. So that means that my a is going to be equal to x, my b is going to be equal to 2y. and I'm going to use this formula in order to factor that x cubed minus 8y to the third power. Why don't you stop this for 1 second, see if you can go through and do that, and then turn this back on again and follow me as I do it. Okay, hopefully you've had time to go through that. Let me go through and factor this. So I have the x cubed minus 2y cubed. I need a minus b, first of all, for this formula that I have. So my very first thing I'm going to have is I'm just going to have x subtract 2y. Then I need a squared, so that's going to be x squared because a is equal to x in this particular case, plus ab. So a is equal to x, b is equal to 2y, so I really have plus 2xy. Then plus b squared. b is equal to 2y, so if I square that, I'm going to get 4y squared. So that factors down to that. The only thing to make sure of, don't forget that we started by factoring out a 4. So I do need to bring that 4 down so I have the 4 included in my final answer, and there's the final answer for the problem. You will need to practice so that you can work with sum and difference of perfect cubes on a test. So this is one area that you might need to memorize these formulas. As always, if I can help you in any way, please let me know.